Okay, so welcome everyone. Welcome to the second webinar of the MARINEWIND project. So I'm really glad to have the opportunity to moderate this second event. And well, before to start and listen from the experts we involve in this session, I would like to give you a very brief introduction of our projects. So, first of all, I would like to share this very short video with you, and then I will spend a few words about it.
The future is green, or is it blue? The true promise for sustainable energy production lies in the ocean, with floating offshore wind technologies. But alongside the promises, this technology comes with many questions. Will these innovations disrupt marine ecosystems? Could they interfere with fishing and transportation routes? Are these technologies considered within marine spatial planning? Are they sustainable in the long run? A lack of information and misconceptions can hinder progress. To move forward, we need to work towards finding answers. Co-funded by the EU, MARINEWIND project will raise awareness of the potential of floating offshore wind technology. The project will also address societal, environmental, and technological barriers and enablers. Our journey takes us to labs in 5 European countries to better understand the application of offshore wind technologies, with the view to foster societal acceptance and to support their commercialization. The MARINEWIND project will also study solutions to overcome the technological and economic issues difficulting the deployment of these technologies. Ultimately, MARINEWIND will support the sustainable use of marine space, facilitating the commercial and technological development of offshore wind planning, while being mindful of the environmental and socio-economic issues, paving the way for a bluer future.
Well, thanks for watching. So I'm Riccardo Coletta. I'm the coordinator of the MARINEWIND project, together with Giulia Butera and Flaminia Rocca, here with me during this session. And so most of the information were already available on the video, so I will be very fast in the next slides. But just a few words about the project. It's a 36 months project. This is the last year, so the job, most part of the preparatory job is already done, but we are approaching to the final results, and we will have some flavor about it with the next presentations. But so we are focusing on three main fold analysis on policy framework assessment, social and environmental impact analysis, and financial and technical economic analysis. And we are support, of course, by the European Union, so with the Horizon Europe project, and by UK RI. We have 2 UK partners. So this is our objectives, our main objectives, but everything it was already explained. But so the main goals for the project is to well, increase the awareness of policymakers, analyze the impact of potential new offshore wind plants, and we'll check and analyze the benefits and possible the obstacles and the enablers of having more plants, mostly in the Mediterranean basin, of course, taking advantage of current examples from the North Sea and North Europe countries. This is our consortium, and that's why we have these countries involved. So we have APRE, the University of York, RSC, CNR, the CNR, Europesh, the Association of Fishermen, Kuplan, Wavek, and Catapult, and we take advantage of UK and Portugal experience for having more information to increase the knowledge and the information for policymaker, for technicians for environmental institutions in Spain, Italy, and Greece, mostly. So our methodology is to include all the possible stakeholders and, well, go as much as possible in deep in the policy framework, in the stakeholder engagement, and checking financial and technical solutions. So these are our 5 countries, as already explained, and we want to go mostly through the analysis and checking our impacts in the regulations. Of course, this is key. Check what's going to happen to the society, and we are not focusing only on the citizens, but also on the economic categories they are directly receive a direct impact from the new plans. Finances, so understanding benefits and financial tools that might support future plans in not only in the Mediterranean countries, but also increase the knowledge for the Northern Europe countries, the better understanding of needs and location and benefit. So this definitely includes the market signals and finally the technology, so the effectiveness of future impact and of course the new challenges of the floating offshore wind sector. So apart from that, so one of our results, it will make available the WebGIS. So WebGIS, it's going to be available on our website, and in our WebGIS you can find a lot of information of the research of the done and with the project, but not only, we can find much more. You can go here, there is the link to go straight to our WebGIS, thanks to RSC, one of our partners, and all the others that provided information, of course. Our webinars. So why we are doing this webinar for our stakeholders? Of course, one of our goals is just to give the opportunity to learn about the MARINEWIND project results, but it's not only the only goals we have. We want to engage and include in the discussions all the stakeholders, all the possible stakeholders, and give the opportunity to have a discussion with the experts involved in the different topics we are facing with our webinars. Of course, understand a bit more about the national, but also the European barriers and enablers for the uptake of the floating offshore winds technologies, and this is one of our main goals. And increase the awareness about the socioeconomic benefit and also for the impact that the citizens will see from new floating offshore wind plans. And, well, collect insights and recommendation, mostly for the policymakers. They are in a key part. They are one of the key parts of the floating offshore wind chain, because we know the regulatory impact and the rules behind the approval of new plants. It's one of the key points, and we have to deal with it, definitely. Just some information about our first webinar. So you can, it's finally available here on the YouTube channel. So if you miss it, so you can go on our channel and check what we discussed last time. It was really useful, and yeah, so go and check, because so the first one was, of course, about different topics, so mostly on environmental impacts and socioeconomic externalities, while this one it's going to be more focused on financial and technological tools. So without wasting more time and just to be on time with our schedule, I'm going to show the agenda. So what we are going to do today. So we're going to have led by Giulia Butera the Mentimeter session in the next 10 minutes, and then we will start to listen from our experts. So insider of the project, so the Ines Tunga from Energy System Catapult, and then Paola Zerilli from the University of York. And immediately after, we will have some best practice insights from Paolo San Martino from Renexia. And finally, we will have our dialogue with Ton Arne Jonsen from Norwegian Offshore Wind, Monica Lucarelli and Filippo Barzaghi from Nadara. And you will have the opportunity to interact directly with our expert at the end of this webinar with the Q&A sessions. And all the webinar will end at 1 p.m. today. So, so Giulia, now it's part to listen from the audience. So let's start with our Mentimeter sessions.
Thank you, Riccardo, and welcome everyone. So we would like to invite you to join our Mentimeter to be used as a quick icebreaker and also to better know our audience today. So we would like to invite you to join us on Mentimeter, so on menti.com, and you can or scan the QR code or enter the code that you see on the slide. And the code will remain available also in the next slide, so you will have the opportunity to join the Mentimeter at any time. So we'll just give you a couple of seconds to join the Mentimeter, and then we will start with the first question. Okay, I see that there are already 27 people joining the Mentimeter, so we would like to ask you to select the best category that describes you. So if we can see that there are a majority from industry professionals. We have 5 experts from the academia. Then we have also representative from policymakers and public authorities, and also from the green innovation sector. We can still see that the large majority is from industry, followed by academia, policymakers and public authorities, and green innovators. So now moving to our second question, which is more linked to the topic of our webinar today. We would like to ask you, what are the most important enabling factors to invest in floating offshore wind technologies? You have different options here, and you can select up to 3 options. So we have the clear regulatory framework, stability of the national transmission grid, potential for development of the local supply chain, large market share and demand, presence of incentives, and then technological maturity. We can see that the need of a clear regulatory framework is the most chosen option, followed by the development of a local supply chain, that again is one of the core topics of our webinar. And then technological maturity, meaning focusing on platform dynamic cables. And then also the stability of the national transmission grid. Now moving to our third questions, we would like to ask you, which is where, in your opinion, is the most significant risk in the supply chain? And here you can select only one option amongst the development of adequate infrastructure, such as, of course, ports, the availability of ad hoc vessels for the installation of the turbines, and the capacity of the supply chain at the local level, which is the most chosen options, followed by the development of adequate infrastructure. Okay, so results are not changing, and we can move to, yeah, we see also the availability of ad hoc vessels, but the majority of the audience seems to vote for the capacity of the supply chain at local level, and of course the development of infrastructures. Now, this is our last question, which is, as you can see, an open question, and we would like to ask you what actions should be implemented to promote the creation of a European-based supply chain for floating offshore wind, since also we can see that from the Mentimeter, the need to develop a local supply chain was really identified as a key priority. So how we can promote the creation of this European or local-based supply chain. Regulatory framework, once again. Fabrication capability. Maritime spatial planning, knowledge. So again, also we will also deepen a bit the topic of the skills today: reindustrialization, pipeline of projects, incentives, stakeholders engagement, educate society, legislation, the grid, LCOE, of course, technicians. So once again, the need of a specialized workforce, the supply chain, offshore infrastructure, technological advancement, clear timelines, hire and train workforce. So we can see that we are in line also with the topic and the presentation of today's webinar. So I will give you the chance to still continue answering this question, but in the meanwhile, I would like to give the floor once again to Riccardo to introduce our next session about the MARINEWIND results.
Thank you, Giulia, and thank you for answering. For us, it's always very, very important to listen from you. So, and of course to receive your questions in case you may have during this webinar. But okay, let me introduce the first speakers now, and are the two of our experts of the MARINEWIND project. So this first session is on leveraging technological and financial enablers for the market uptake of floating offshore wind technologies. And I would like to start with Ines Tunga from Catapult. She's renewable practice manager at Energy System Catapult, and is responsible for renewables and impact on UK energy system. So she is experienced subject matter expert, driving value across renewable energy projects covering electrical machines, material, hydrodynamics, manufacturing, and so on, and marine operation, of course. So Ines, so the floor is yours for your first presentation.
Thank you, Riccardo. I'll share my screen. Right, good morning, everyone. Yes, my name is Ines, and Riccardo, thank you for the introductions. I'm part of the Energy Systems Catapult, which is part of the Catapult network with 9 different centers. We are partly funded by Innovate UK, And our role really and our objective is to accelerate the transformation of UK energy systems, ensuring that businesses and innovators as well as consumer kind of capture the opportunity for clean growth. So for today, I would like to explore some of our results in the techno-economic areas essential for floating offshore wind. We have worked in this space for a while. We have done a lot of survey, workshop and analysis and modeling. So this is a screenshot, really a snippet of some of the results, but there's quite a lot of information behind all this. Before I jump on to a lot of the results, I thought we can take a step back and look at what's going on in the sector at the moment. Hopefully you can see the slide properly. In this slide, it's one slide from Offshore that kind of highlight where we are going in terms of deployment of floating offshore wind globally at the moment. And this actually shows the Europe and the prospect of what we see we can achieve by 2040. We have about 40 gigawatt plan for construction by 2040 in Europe. And what this slide shows is which countries with different colors will have the different capacities. Now, this is a positive picture, but as we grow to net zero, the demand to scale up, not just in offshore wind, but other renewables will be needed and will increase significantly because as the electrification of transport industry and heat is expected, we need to double the current electricity generation to actually make up for what is needed. Floating wind is one of those solutions to meet the demand, and this graph kind of captures the potential output for that by 2040. In addition, we also see other picture. I clicked here. I introduced this graph as well to also see the market, because that's an element that came on the back of the Mentimeter, the regulation, the market. But this also highlights globally where we also see the attractiveness of the market in terms of the potential, in terms of regulation, in terms of the supply chain readiness, and all the different ambitions that are already in place in different countries. Interestingly, we see the picture slightly changing, and this is a reference from Foresee Offshore Wind as well. Now, that is the positive part of where we are and what we are hoping to get to, but there are a lot of challenges, and this was the recent blackout in Spain that also impacted Portugal and others. Interestingly, there's still a lot of information and news and different opinion coming into play. But what I wanted to highlight here is as we put more and more renewables into the system, into the energy system, we also need to understand what are the integration challenges that come with it. Now, we are currently using a system that was designed for fossil fuels, centralized with inertia to provide the resilience. As we scale up, so as we get to the scale up of renewables that we need, floating wind included, we also need to update, we also need to redesign our infrastructure so that they can cope with renewable properties or characteristics. Here I'm talking about the inertia. The renewables doesn't provide the inertia that fossil fuel used to, so there are other solutions that come with it, flexibility, synthetic inertias, and others. So as we continue to develop this, we also need to pay attention to the system as a whole, the infrastructure, the grid, the system operability, and managing those challenges as well. Across the waters, we've had, well, in the UK, we had recently Ørsted pulling out of one of the Hornsea 4, so it's big offshore wind farm that was in planning. In the US, we saw some of the noises around Trump administration pulling out of some of the investment into offshore wind. So all those are not a lot of the challenges in the Mentimeter. Interestingly, there were clear regulatory framework, getting the supply chain, getting the transmission. We had local content, and we had also getting the infrastructure ready. So with all the uncertainty around our systems, around the administration, around investments, this is what I wanted to talk about, the technological barriers and enablers for floating offshore wind. I tried to summarize some of the work that we have done here into technological, non-technological, and systems integration challenges or barriers. And this is what I'm presenting here. So from the cost itself, looking at standardization of some of the design in floating wind particularly. Now, we also have different sites that have different properties and different characteristics. We are looking at high impact, we are looking at low cost, but like some of the respondents in the Mentimeter, we also need to get to maturity. We need to get to the readiness level where there's less risk in investment, so the cost is lower. In terms of grid constraints, standardization touch on, we now have dynamic cabling to provide that robustness and flexibility we need. There's a challenging of managing the power transmission. I talked about the grid already. In the UK and elsewhere as well, now we start having the challenge in offshore wind on curtailments, where there's not enough capacity for the grid to receive the produced energy. So we are looking at, there's a lot of work ongoing in the UK, looking at connection reforms. There's a lot of work looking at flexibility services, better forecasting using AI, digitalization, control system to better integrate and for better resilience of the system. And I realize I'm already 7 minutes in. Maintenance challenges, so machine learning, how do we get the right ports, the right vessels, the logistics to support supply chain, the ports, the manufacturing capabilities. And on the non-technological, we have already touched on the workforce and skills. We talked about regulatory, we talked about the market signal, data, digitalization, and others. So these kind of capture at high level the key barriers, looking at the key enablers, kind of obvious based on the barriers already. So the technological enablers from standardized, scalable design, I touched on AI, digital twin, remote to provide that remote monitoring. On infrastructure, we need infrastructure. We need to triple. In the UK, there was a picture to get to 2030, our 2030 goal. We need 5 times more infrastructure to actually support the integration of renewables that we want to get to. But we also need the market, reform contract for difference, PPAs for revenue certainty, grid access, shared infrastructure, planning and permitting are still very slow, so streamlining those. But also on the systems integration, modernizing the grid, reinforcing the current grid. There are a lot of solutions such as HVDC links that have been already deployed, smart grid support and storage, hydrogen, other flexibility and stability solutions. We're not touching on policy, but we can't do all this without policy, clear strategy in place for long-term visibility. We need the funding, R&D funding, pilot projects. We need workforce, which not just for floating wind, but for us to actually get to net zero. So lots of challenges, but a lot of opportunities for us to advance the sector, or for the government and for policy, for developers to actually advance this. And quickly finishing with my last 30 seconds, this is a model that we developed to start understanding co-location opportunities. Now, I mentioned earlier some of the challenges we have is to get what is produced, the generation or the green generation to the grid. And as curtailment, as we are looking to reinforce the grid, there are also options to look at co-locating floating wind with either other renewables, but also to hydrogen, for instance, if it's needed. So this was a study that we did trying to understand the business case for co-location, trying to understand the techno-economic parameters and profile of these. We will have a report out by the end of June, so that will detail out some of the finding and where we see the case for this in the UK. But this just highlights some of the cost-related CapEx, as well as some of the when it makes sense to have that flexibility. I think I'm at time now, so I'll stop sharing, and I believe I'll take questions at the end of the session. Over
Yes,
to you, Ricardo.
indeed. Yeah, thank you, Ines. Really valuable contributions to possible discussion later on, but also a lot of very interesting inputs for us. Yeah, so the discussion on the grid, it's really update because we have this well, EU level. Okay, it was mostly in Spain and Portugal, but it's the EU level concern about the future of the renewable energy. So it's definitely really interesting, and of course we will look ahead to check further information and further insights from the project research and beyond, of course. Thank you very much. So, and we will have the opportunity to discuss during the Q&A session. And now let me introduce Paola Zerilli, the senior lecturer from the Department of Economics at the University of York. Paola has a solid experience in applied financial econometrics with a clear focus on energy derivatives. So she's the scientific coordinator of the MARINEWIND project, but she's involved in many other EU projects on renewable energies, and she will give us an overview of financial barriers, which is another key point of our projects. So, Paola, I don't want to waste all the time, so I'm going to give you the floor.
Thank you, Ricardo. Good morning, everyone. So today I'm going to talk about the survey that we ran across the MARINEWIND countries, and we are going to talk about the barriers and enablers from a financial point of view. Also, I'll give you an initial flavor about the financial tool that we are preparing as part of the MARINEWIND project, and that will be available online very soon. It will be as a support exactly to the solution to these financial barriers. Okay, so you can see my screen. Yes, sorry. One moment, because okay, all right. Okay. So we ran this survey across the MARINEWIND partner countries with a diverse mix of stakeholders. We had 540 participants in Greece, Spain, Portugal, UK, and Italy. As you can see, about 20% of our participants were from academia, and then across industry and fisheries, investors in finance, etc. So as a result of this survey, what came out is that there are some recurrent financial barriers that keep showing up. For example, the high capex premium that is increasing the cost of creating these technologies by about 30%. That is related to floating foundations, dynamic cables, and bespoke port works. Also, the constraint to supply chain, they are they're increasing the cost, and the expensive or scarce debt that is increasing the price for borrowing money by 150 or 200 basis points for maturities up to 10 to 12 years, that they are not enough for this type of investment. Also permitting a grid bottlenecks, they are pushing up the cost and the wholesale price volatility. In general, also the volatility of energy markets is also a problem. And as part of the Marine Wind project, actually, we are taking that into account in our LCOE general tool that I'm going to show you. Just I'll give you a flavor in a minute. In our studies and also through the Marine Wind workshops and going to conferences, particularly involving the private sector and the industry, what came up is that there are some optimizing incentives and funding mechanism, and this is also what we observed from the survey. So, for example, from grants, and they are very, very helpful from the government. And also concessional loans to cut the cost of capital, and floating some specific contracts from the government. For example, a contract for different auctions are very helpful as well. This type of contracts, they've been used a lot by the UK government, and also now other countries are starting experimenting them. What we have observed is that sometimes this type of contracts, although they are very supportive of the investment in this type of technology, they are often related. How their effectiveness depends on the size of the plant. But sometimes with them, when they are also combined with supply chain co-investment funds, then they are a lot more effective. And this is what exactly we have observed in UK. Also, the risk-sharing instruments, they are very effective in order to decrease the risk in this type of investment. So also, again, contract for different auctions, they are a revenue stabilizing tool, because in practice the government agrees to buy electricity from the producers for a number of years, and in this way ensures a kind of a stable source of revenue for a long time, and combined also with long-term power purchase agreements, they work in the same way. Also, in other European countries, innovation funding investment grants that are supported by European Investment Bank, they are very effective as co-financing mechanism. And the supply chain accelerator fund is what we have observed in the UK, that is working really well in order to support this type of investments. So also in the survey, other innovative co-financing mechanism came up, such as, for example, public-private blending finance platforms and green and blue bonds. We are going to, by the way, we are going to make public more details about this source of financing through our deliverables on our website. And also we are going to put more details in our LSOE tool as well. What else? The original equipment manufacturer performance warranties also, they are very they are a source of co-financing mechanism, and they guarantee against defect, and they assure a minimum availability level for the equipment. Okay, so what I wanted to do now was to show you, because you remember I was talking about, sorry, do I have a little bit more time, Riccardo?
Okay, just 1 minute.
Just 2 minutes, okay.
Yeah.
Because I just wanted to talk about, just give you a little flavor about our LCOE simulation mechanism that is going to take into account exactly the volatility of the markets and provide, so we are going to make it public in the next couple of weeks. We are just making a few refinements, but this will help exactly pricing giving the cost of setting up this type of technology, considering also the volatility in the macroeconomic variables and in energy market as well. So this tool is so the user will be able to input the preferred currency, also the size, the capacity of the plant, the share of equity, the initial inflation rate that is going to be also simulated for the future. And so also this tool will take into account the fluctuation in interest rate and in inflation as well. And is going to provide
30 seconds about
is going to provide the general cost of electricity, the realized cost of electricity, considering all these macroeconomic variable and also the volatility in energy markets. Okay, so and of course it's going to provide the return on investment on this type of in investing in this type of technology. So we are going to make it public in our website in the next couple of weeks. Okay,
yeah,
thank you.
Just was saying, so just stay tuned on our results, because so thanks mostly to the so Paula staff job, you know, we are going to have this results in a few weeks, months, I think, because we are getting close.
Maximum a couple of weeks. It is almost ready. We are just making the last adjustments. But the innovation compared to other existing tools is that exactly all the volatility in financial markets, in energy markets, will be taken into account. So that is what actually is more risky in this type of investment, and will provide also the return on investment on this type of technology. Yeah.
So for more insight, maybe you will have the opportunity to make some questions in the Q&A session later on. Thank you very much. Thank you, Paula. Thanks, Ines, for your interventions. And now we are really glad to switch to concrete action implemented by Renexia to support the creation of the national supply chain for floating offshore wind, starting from the experience of MARINEWIND project. So, and just because of that, I would like to leave the floor to Paolo Sammartino, Chief Operating Officer at Renexia. So, Paolo, the floor is yours.
Yeah, thanks, Riccardo. I will try to share my screen in a second. Okay, should be able to see. I prepared some slides for the topic we will speak in these 15 minutes. First-hand insights, the Renexia case. Renexia case mainly because usually when we start a project, we try to let all the stakeholders be involved since the inception of the project. So, we are speaking about stakeholders from state agencies, local agencies, private entities, and so on. And so that's the reason why the Renexia case. And specifically, we will speak about our recent project we are developing. It is the MARINEWIND project. By the way, we have been, let's say, sort of pioneering offshore wind in Italy because we have built the first and only at the moment. We hope that in the next future there will be more and more offshore wind project here in Italy. This is a pilot. It's a 30 megawatt project in Taranto that actually is running. And we are continuing to put efforts on the offshore wind space. And so the MARINEWIND project here in Italy is the next cornerstone project we are concentrated. The MARINEWIND project actually in development is a project that involves the construction of a multi-section offshore wind project. Actually is divided in 4 sections, and we use it for these 4 sections, the name of the winds, Sirocco, Grecale, Tramontana, Maestrale, and so on. And that for technological issues, but also to have the flexibility to develop the project in different ways. Actually, we are speaking about up to 190 turbine generators with an overall rated power up to 18.8 megawatt and with an annual energy production between 8 and 9 terawatt hour a year, depending on the turbine selection, on the power curve performance, and a lot of technological aspects that will be taken account to make this energy yield assessment. We know that we are challenging, we have challenging conditions. First of all, the water depth that in some areas arrives at 865 meters, and the distance from the coast that is also remarkable because we are at 80 kilometers from the coast, with a total nameplate of 2.8 gigawatt, more or less. As I was mentioned before, we have been very active in making a lot of engagement for local stakeholders and for all the activities that these kind of projects need to be needed to develop such kind of projects. First of all, the surveys. The surveys are, let's say, the core of a project development when you are at sea. And for the surveys that we conducted on the MARINEWIND project area, we involved the Italian Navy, the Zoological Station of Naples from Anton Dor, Fugro Italia, and this in order to have a side scan sonar, sub-bottom profiler survey, magnetometer, bathymetric survey, acoustic monitoring, avifauna research, ROV transect, and archaeological side scan sonar jointly with the magnetometer analysis. Last but not least, is not in this slide, we are completing the geotech activity. We have 15 days more of geotech activity, and we are investigating each single turbine location with CPT and also with coring of the seabed. So because we believe that this first part is very important to substantiate the capex. I heard that before my intervention there was a very interesting talk regarding capex sensitivity. We believe that in a project like this, to do all these surveys is important, to not put on the table uncertainties in terms of capex definitions. On top of that, we had surveyed north and south pipeline corridors and landings. So there is an error. It's not pipeline because we are not speaking oil and gas, but it's export cables. So please forgive me, because this project actually is connected to the grid via two links. I can go back and you can see. I can zoom in this slide. You should see. You should see that we have these, very thin lines that from the projects arise at inland. So one is north and one is south in blue and yellow, barely visible, but these are. And basically what we have done is that we made survey even for these corridors in order to avoid not seeing potential threats for the project and not seeing potential alternatives that we would love to provide to the stakeholders and to all the state and government agencies that they are screening on this project. First of all, MASE, we so-called MASE, that is, the state agency that is actually evaluating our project. On top of that, we made also some surveys onshore, because these kind of projects, they have a very important onshore part that we can see. We can say that the onshore section of these projects is mostly like a project inside a project, because we are speaking about important grid reinforcements, and so in order to connect this project to the Terna Italian grid, that is the Italian TSO. Here I'm just showing some pictures of what we have done. You can see that in the upper left part there is all the technicians that have been involved in the service, and one of the vessels we use it during the service activity. And on the right you can see some survey related to activities for sampling and ROV. And then I can show you what we found, something we found at sea, because you can see that we have seen some shipwrecks. Here in the bottom left you can see a picture, and there is the name of the vessel, and that is a vessel so-called Monte Pellegrino, and that was a 50-60 years a vessel that was sank in the area, and we investigated with the survey, we described it. And then there are other strange things that you can see below the sea level. For example, in the bottom right picture, you can see the US Navy fighter bomber that was found during the survey. I mean, it's hard to believe that you can find down there a US Navy fighter bomber, but that's the beauty of doing survey in order to see what you are gonna to develop in your project. And by the way, that was also, important for the stakeholders. And so I'm coming back to our involvement with the stakeholders, because all this data, all this information, they were shared with the stakeholders in order to let them improve the knowledge of an area of the Mediterranean Sea that was very, very poor investigated. And these are some pictures from ROV survey, and these are trenches that they were created by more and more fishing activities. And I'm speaking about trolling fishing. That is, trolling fishing is something that can hurt very deep the seabed life. And the proof of that is that in all of our survey, we saw that the life on the seabed is very poor, because having this kind of activity for decades can create such situations. Going back to stakeholder engagement, for us is important also to stay close on the entities that live. They use the sea for their economic developments, and the fishing sector is one of the sectors that is more and more linked with the offshore wind developments. And in order to make something that is sustainable also for them, we for the MARINEWIND project, we are always in contact with the fishing representatives, and we made a study that can show the compatibility with the project, between the project and the fishing activities. And for example, here you can see in this picture that based on available official data, is it possible to estimate that the change in value of the level of occupation could be improved for the fishing activity in developing such kind of projects. And speaking about again about the impact of the study for the fishing sector, it's important to underline that Renexia actually had a fruitful dialogue with all the trade unions in Sicily, because the project is in Sicily, like CISL, CISL, UEL. All of you that you are Italian, you know pretty well these trade unions names, so they are the most important in the work sector in Italy. And the aim is to jointly assess further project definition, and that in order to benefit all the people that will live with this project. And so with concrete actions like modernization of engines and also improvement of the fishing gears and all this kind of stuff. So actually in this slide you can see, all the strategic partnership that I mentioned before. So all the names that you see here, they have a strategic partnership with us, starting from Marina Militare, arriving from Legambiente, Kyoto Club, and so on. And you can see that in this picture you have all these guys, and in the middle you have MARINEWIND, because this is the way we believe such project has to be developed now and in next future. Thank you for your attention. I try to stay in the 15 minutes, so.
Yeah, thank you. Thank you very much. And yeah, most of all, thank you for the contents you provide us. Really interesting, you know, checking the scan of the sea bottom, and of course all the interaction with the stakeholder involved. We know that it's a huge work, and you have to look in many different directions. I'd say when you approach such a big plan. So thank you very much for your experience, and again, for the audience, you will have the opportunity to make questions in the very last part of this webinar.
Thanks, Ricardo.
Thank you very much. So now we move to our dialogue, so the fourth session. And I'm happy to introduce here Tor Arne Johnsen. Tor is the EU advisor for Norwegian offshore wind. It's the largest industrial cluster in Norway. They have 400 member companies, and he personally has a master in economics, and he works previously for the Ministry of Trade and Industry, and of course as a EU consultant. Together with Tor, we're going to have Filippo Barzaghi and Monica Lucarelli from Nadara. Nadara bring together 30 years of combined industry experience, and is one of Europe's largest renewable energy industry, and installed 4 gigawatt portfolio and 199 plants, including onshore wind, solar, biomass, and energy storage, and a pipeline of 18 gigawatts. So we would like to have a discussion with all of you, and we would like to have an insightful discussion on the perspective of how to scale up a competitive and resilient European value chain. This is one of the main topics of the webinar we are having today, mostly, of course, in offshore wind. Bridging market deployment, policy stability, and when possible, supply chain readiness. So I would like to start with my first question. So which share could represented by offshore wind in the energy mix to reach the carbonization objective by 2030 and 2050, considering the debate about its production performance? And so the very second one is how to successfully mobilize public and private investments for existing plants or for future plants to be developed. So I will let to Tor firstly.
Do you want me to start?
I can hear you. Yep.
Yeah, do you want me to start? Yes, Tor Johnsen from Norwegian Offshore Wind. Thank you very much for coming here and presenting a little bit about our views on these areas. We cover mostly the North Sea. That's kind of our home market, but we also have a lot of work on the Mediterranean Sea. When it's come to the question here, I think as also mentioned earlier, the main feature is kind of the LCOE, or the levelized cost of electricity. I think that's kind of the main issue around these questions, because it really goes down to the business case. If you want a developer to invest, then you need to have a strong business case. And in this section, offshore wind need to compete with other type of renewables. So in a way, you need to reduce the LCOE. Today, the LCOE is on bottom fixed is from 60 euros per megawatt to 90 euros per megawatt. Floating is in another scale. It's from 120 to 160 megawatt. That was also presented earlier today. In 2030, we expect both of these to be halved in price. It means bottom fixed 40 to 60, floating 70 to 100 euros per megawatt. So, and how should we in a way reduce the LCOE? I believe the developers after me will focus mainly on the regulatory permitting and also pipeline of project. So I will focus mostly on what's important for the supply chain, because that's where we come from. We cover most of the supply chain. And the first part of the supply chain is kind of the thing we see on the interest rate. And also inflation. If you're going to invest in new vessels, if you're going to invest in new wind farms, you probably need to loan the money. And then the interest rates are quite crucial for the project. That's outside our scope to do something with. It's kind of the government, but it's important to look at both the cost of capital that has been huge, but also the inflation. That means that the products and services is also getting more expensive. The two areas that especially the supply chain can do something about, that is the supply chain constraints. When it's come to number of vessels, when it comes to fabrication of turbines, when it comes to grid, when it comes to cables, all of those type of activities, the industry can do something about. But if we're going to invest in those type of capabilities, we need to have kind of a level playing field, and we need to have kind of a framework that says that it's a lot of project coming. When it comes to the floating, also it was also mentioned about this risk that you pay for floating. I believe most of that risk is in the technology aspect. You are setting things in the water that has never been done before. Then you need to pay that type of risk. And this is something that we believe will be solved by the industry. The industry have done large projects before, for example, in oil and gas, and we are now also going into the floating offshore wind with the first big projects coming. In Norway, we have had a lot of projects. UK, Italy is also coming with larger and the first industrial project coming. So we believe in the future is going to be a lot of cost reduction based on the way you do it. You learn the learning by doing effect here is quite huge, and that is something that is hard to measure, but we believe it's going to happen in floating. It has happened on bottom fixed project so far, and we believe it also will happen in floating. I believe that's my 5 minutes.
Thank you, Tor.
Thank you.
Thank you. Yeah. So, but so staying on the same topic, we would like to hear from Filippo Barzaghi.
Yeah. First of all, thanks, Ricardo, for the introduction, and thanks to you and your team also for the invite to this webinar. I'll try to complement a bit, let's say, bring the developer's perspective. First off, to understand well the potential role of offshore wind and especially floating in achieving decarbonization targets by 2030 and 2050, I think it's worth starting with a few key numbers and key figures that, let's say, illustrate the scale of this sector. As we probably all know, globally, the pipeline of new floating offshore wind projects has now reached 266 gigawatt. And of course, while not all these projects will eventually be built, because of course there is a certain mortality rate, the scale alone, I think, highlights the sector's growing importance, and also, let's say, its clear potential to contribute meaningfully to the future energy mix. And in Italy, for instance, the offshore wind is expected to reach 10% of the energy mix by 2050, so it's a huge contribution. And the technology itself has already proven at the demonstration level, and the focus now is, of course, on scaling up to industrial capacity. And we all know that in this respect, 2024 was a turning point, because we've seen that 5 large-scale floating projects secured off-take contracts representing 1.9 of gigawatts. So that's for sure an important step towards commercial maturity. But before we discuss the second question, so how to mobilize public and private investments in offshore wind, which is for sure a critical point, I think we need to take a step back and ask ourselves why it's worth investing in the technology in the first place. Because so far, I mean, I just focus on the percentages in the energy mix or gigawatt of capacity and etc. But that only scratches the surface because offshore wind and floating especially, it's not just a means to decarbonize. It's let's say a strategic enabler for reshaping, let's say, our energy system to let's say reinforce our sovereignty and our security, and also to create, as speakers before me told, local economic value. So this is the broader rationale for investing in it, and it must guide, let's say, how we approach the support frameworks and the market design. And in this context, just to give you a very concrete example, Italy stands out as a particularly compelling case because at the moment there are no other credible alternatives to achieve those ambition targets we were talking about. Because, as you know, there is land availability which is limited, low impact on shore sites are quickly running out. Italy has one of the windiest coastlines in the Mediterranean, industrial network along the coast. So, and also on top of that, there is a urgent need to decarbonize. So it's now clear why we need offshore wind and especially floating in Italy. And then we can move to the next question. So how do we make that happen? Well, from our perspective, to unlock this potential, there are at least 3 enabling conditions to be put in place. The first one, and is a recurring condition, is a stable and transparent regulatory framework with timely and well-defined auctions, both in terms of volumes and calendar, because without them, of course, investors cannot plan, and financing conditions, let's say, remain uncertain. And as you all know, probably Italy, for instance, still lacks an auction schedule for this year. So this is a clear barrier to market confidence. So that's the first point. The second point is a bankable revenue mechanism. Two-sided contracts for difference are now the standard to reduce the merchant risk, and that's okay. However, from our perspective, they're not sufficient on their own, let's say, especially for these capital-intensive projects like floating offshore wind. And again, from our perspective, to be fully effective, CFD must better reflect the real financial exposure that developers face throughout the whole project lifecycle. And this means also adopting a more comprehensive indexation approach, not only to inflation, to national inflation, but also to global commodity prices. Especially because while the need for indexation is understood during development and construction is well understood, I would say, given the sensitivity to materials like steel, copper, etc., the operational phase, I think, is often underestimated. And yet, in reality, these long-term assets continue to have significant cost pressures also into their operating life. And this include, of course, inflation-driven increases in maintenance costs, spare parts, logistics, and labor, all of which are subject to global market dynamics. So without stable indexation through all the phases, CFD alone risks offering only partial protection, leaving developers exposed to long-term financial uncertainty. And the last point, and I will be very brief, it's a long-term industrial strategy and coordinated infrastructure planning, because this large-scale deployment of floating offshore wind require an integrated approach that combines, let's say, industrial policy with infrastructure development. And a clear national strategy can help align public and private efforts and also promote the localization of manufacturing and services. But at the same time, suitable port infrastructure and grid readiness are essential to support project execution, because planning these elements in advance can, let's say, maximize local economic benefits and also ensure projects are delivered efficiently and at scale. One last point, Riccardo, and then I'm done. I just want to mention that in this increasingly competitive global market, these 3 enabling conditions would allow to mobilize investments, build up a world-class supply chain, and achieve the economy of scale we're talking about. And we need to drive down the cost as fast as possible. And in Italy, in our specific case, I can tell you that the developers are basically ready to run, and some are already running. But we need, let's say, a race map, not just run issues with a clear policy signals. Because if we finish late, let's say, we don't just lose time, we lose market shares, we lose supply chain controls, and also the chance to be price setters instead of price takers. So that's all.
Yeah, thank you, Filippo. And some of the well, the topics you raised up during your intervention, but the one done by Tor as well, just bring us straight to the second question. And well, indeed, we have to find investment. We have to increase the scale up to the floating offshore wind industry and European capacity. But, and this is a discussion also also done at the level of the European Commission. It's how to work together with the industry sector or with the research and investment and innovation sector to bring the supply chain and also all the value chain in the EU, because now it's we are a bit far from our targets, and so just because of that, our second question is on these fields, and is what you can see on the screen, of course, what are the main gaps to be filled in for the creation of the potential European-based supply and value chain for floating offshore wind. And this time I would like to start with Monica Lucarelli. So Monica, you have some answer for us?
Thank you, Riccardo. Good morning, everyone, and thank you for inviting us. It's a pleasure to be here today to discuss one of the most promising frontiers in the energy transition, as floating offshore wind is, in our opinion. When we talk about unlocking the potential of floating offshore wind in Europe, we must look beyond technology readiness. The real challenge and the real opportunity is representing by building a robust and scalable and competitive European supply chain and value chain. And to do so, we must address three key gaps: skill, infrastructure, and manufacturing capacity. So let's start from the first gap. In our opinion, is skills. Floating offshore wind requires a broad mix of expertise, not just in wind energy, but in offshore engineering, naval architecture, mooring system, composite materials, steel, digital technologies, and more and more. And yet today, there is a clear mismatch between the current workforce and the skill needed to scale up this sector. We needed to act on multiple sides, updating vocational and university curricula, supporting cross-sector retraining, especially from adjacent industries like oil and gas or shipbuilding, and investing in lifelong learning. We must also make this sector attractive to young talent and diverse profiles. Without a skilled and multidisciplinary workforce, the value chain simply cannot grow. The second major gap is infrastructure, particularly the port infrastructure. The floating offshore wind demands large coastal areas for assembly and pre-commissioning of floating platforms, as well as heavy lift capabilities and deep water access. Currently, very few ports in Europe meet these logistics requirements. For example, as we see Port La Nouvelle. To enable industrial scale deployment, we need to upgrade and adapt existing ports, and in some cases, develop entirely new hubs dedicated to floating wind. This requires long-term planning, public and private cooperation, and significant investment. This also means countries must work together, thinking regionally and coordinating across countries to avoid duplication, planning investments, and foster synergies, creating stronger results through cooperation. The third gap is manufacturing and industrial capacity. Europe has strong foundations in wind turbine technology, but floating wind introduce new components such as floating foundations, dynamic cables, advanced anchoring systems that require different material, processes, and scale. Today, the manufacturing capacity for these components remain limited and fragmented, and in some cases reliant on non-Europe suppliers. So if we want to build a truly European value chain, we need to localize production, invest in automation, develop standardized, scalable designs. And we must do this in a way that ensures competitiveness, quality, and sustainability. At this point, let me add fourth cross-cutting gap, in my opinion, very important. This is coordination. So to fill these gaps efficiently, we need a coordinated European industrial strategy for floating offshore wind. One that aligns national plans, de-risk private investments, and connect the dots between R&D, permitting, skills, infrastructures, and procurement. We cannot afford to work separately in silos. In each country, try to build a separate value chain. We will dilute resources, increase cost, and slow down the growth. But if we have together as a true European ecosystem, we can create economies of scale, reinforce strategic autonomy, and become global leaders in this field. In conclusion, the potential of floating offshore wind is big, very enormous in our perspective. But to realize this, we must treat the supply chain as a strategic asset. And so Europe has the talent, the technology, and the ambition. What we need now is urgency, coordinate across government, industry, and civil society to invest in people, in ports, and in production. Thanks.
Thank you, Monica. Thank you very much. Yeah, so I guess that that yeah, the supply chain and the value chain again, it's really complicated and should be put and the attention on many different issues. And just to complete the answer, also on the perspective of Thor, I would like to involve him, and of course the Norwegian offshore wind. I would like to involve him as well in answering to these questions. So, Thor.
Yes, thank you. We completely agree with Monica on this. I think she made crystal clear the arguments, so we concur on those. So I will now try to, in a way, come with some examples that in a way underline the main messages that Monica posted here. Firstly, we have made an analysis of European content in European offshore wind projects. This is together with TGS 4C. We had made this analysis, and it shows that it depends on which segment in offshore wind, but European content goes from 70 to 80% when it's come to turbines, when it's European projects, down to 50% when it's come, for example, to other segments. So in European project, European offshore wind projects in Europe, European suppliers has a quite strong supply chain and have a market share that is fantastic. Outside Europe also, European companies has a very strong market share, in some area 40 to 50%. What will happen, with the global phase that we are in now, I'm not sure, but on the export side outside Europe, it's really a challenge for those 40 to 50% that is kind of European suppliers into projects. That was my first point. My second point, and this is kind of I'm challenging a little bit, and that is it's a trade-off between local production and costs. So just keep that in mind when we're talking about European supply chain. If we're going to develop local supply chains, now I'm not talking about national or European supply chain, I'm talking about local supply chain, it will probably be more expensive than importing issues from other countries, or for example China. So just keep that in mind. It's a trade-off here, and as I mentioned earlier, the business case in offshore wind is not good at the moment, you know, as I mentioned, with the interest rate and inflation. So keep that in mind. A local supply chain base is probably not cost efficient. We need to do it in the right way. And just to cover or just to highlight what Monica was talking about, European supply chains, because as mentioned, in floating offshore wind especially, it's economic of scale. That means that you probably is going to have very few ports doing the assembly, but those ports are doing a lot of assemblies. In other areas also, when it comes to turbines, when it comes to cables, floaters, you're probably going to have economic of scales. That means that not every country should probably have fabrication capabilities. Some countries should, but not everyone. And just to mention some of the projects in UK on floating and also in Norway, most of the fabrication has been done in Spain. The floaters has been towed up to the Norwegian coast. It has been assembled there with turbines, generators, everything, and towed over to Denmark, no, over to UK, or installed in Norway. So, and this could be the way forward, that we have a smart specialization in Europe where we have different countries specializing on different issue of the supply chain. When it comes to skills, we are really in a hurry, because skills and getting the right type of competence, it doesn't take 1 year. It's probably a 10-year period for this. So this is, we are in a hurry in a way, fabricating or getting educated the right type of people. In Europe says we need 500,000 wind technicians by 2028, and there are big bottlenecks on creating those 500,000 wind technicians, and in other fields it's the same. When it comes to installation, I want to point out 2 specific areas. One is the vessels, installation vessels. Today, it was mentioned earlier by Renexia, the turbines that is going to be installed, it's not 4 megawatts, it's 15 plus megawatts. So they are quite large, and you need to have installation vessels that could take those type of turbines. Globally today, it's about 20 vessels that can do that type of job. For just the North Sea, you probably need 50 of those. 50 vessels doing the installation. Today, globally, it's 20. And why doesn't these vessel owners invest in enough vessels? Firstly, it's costly. 1 vessel, probably 700 million euros. That's one area. Second area for them, the pipeline. What type of project are in the pipeline? On floating, it's not a lot, and they are scattered all over Europe. And thirdly, when it comes to fuel, what type of fuels are those vessels going to use? With the taxonomy, in the future we expect it's going to be green fuel. What type of fuel does those type of vessels need? These are risks. These are big risks. That's just one example. The second example, it's ports. We probably need 10 to 15 major offshore wind ports just in the North Sea. They are not ready today. They need to invest. They need to invest in all from cranes and also in what's called wet storage areas. It's a lot of money that need to be invested in this, and they will not do an investment before there is a pipeline of project and they are getting the contracts. So it's a kind of a chicken and egg problem in getting the ports ready for the floating offshore wind business. So, and also the fabrication in competition with, for example, US and also UK, that it's outside the EU, it seems much easier to set up schemes that in a way foster investment in fabrication capabilities that Europe cannot do today. And this needs to change. So I think that's enough from my side now.
Thanks, Thor. Thanks. Yeah, I think that there's a lot of work ahead for well, for the EU industrial system, and well, in particular for we're working on our supply chain. But so and this is going in the same direction. So we want to just close this this session with the very last question, and it's about how, you know, that the industrial sector and all the supply chain and the value chain sector can be supported by policy and policy regulators. So, and just because of that, our third and last question is what intervention are needed from the policy and regulatory perspectives, especially in terms of incentives and protection measures to enable the establishment of a fair and sustainable environment for the European wind manufacturers. And so, Thor, we would like to well, involve you once again to answer, and I think this the discussion with perfectly flows into this third question from your last intervention.
Yes, thank you. I just want to highlight the main issues here, and I think it's important that it takes two to tango. The people that tangos, it takes two to tango. So you need to have an industry that really needs that meets the needs, but at the same time you need to have a governments, and I'm talking about governments, not a government, that really also need their side of the bargain. And just to highlight in a way the 5 main points from our side, this has been mentioned, so I will not go into details. Regulatory and permitting processes need to be accelerated. In this, also grid infrastructure need to also be accelerated, especially in the North Sea. The grid situation is a challenge. It's probably not in Italy, but in the UK and Norway, grid capability are a challenge. Secondly, pipeline of project, you need to have CFDs that in a way cover the costs. Thirdly, as mentioned, interest rate and inflation, that is hard for us to do something about, both the public sector and the industry. And the two last, supply chain development and the technical aspects. Those 2 areas is something that the industry should do something about. And I foresee it was also presented by Wind Europe in Copenhagen, kind of a green sector deal. And the green sector deal presented in Copenhagen was that if the government of Europe have a pipeline of 15 gigawatts of project per year, the industry will reduce the costs by 30%. So it's a kind of a two-way street here. If the government provide those type of incentives, then the industry will also deliver on costs. So that's the main point. One area that I think also should be taken into account, and this is kind of a pan-European approach, is that if you look at the auction, especially in the North Sea, and installation, and all that, most of the country, this is going to happen in the same areas and also in the same years. So you will kind of having a huge bottlenecks of project going to be installed both on the UK side, Norwegian side, Belgian side, Netherlands, and Denmark side. So there should be somebody talking above us about a better system for the supply chain to deliver, because it's hard for the supply chain to deliver on 60 gigawatts. That's kind of the objective in the North Sea by 2030 at the same time. It should be scattered all in all years, so to speak. So the supply chain could in a way take and solve the challenges. So that's it from my side. Thank you.
Thank you so much.
To complement the view, from our perspective, we need at least two types of interventions, let's say. So long-term visibility. So again, this point comes up again, and a fair competition with targeted support. And well, let me briefly explain each of those, and then I leave to Monica for further integrations and comments. For the first point, so let long-term visibility through stable and strategic auction design. First and foremost, one of the biggest obstacles for wind manufacturers today is uncertainty, as for developers. So without predictable multi-year auction schedules, company cannot plan production, invest in new capacity, or neither build up a skilled workforce. And this applies both at the national level and at the European level. So stability and clarity are essential to give industry the confidence to scale. But it's not just about how much capacity is auctioned, it's also about how we design those auctions. The current price only logic is no longer sufficient because, for instance, in Italy at the moment, the current fair to mechanism is, let's say, auctioned in a way in which the only criteria is the price. Europe needs to move towards auctions that reward added value via different criteria, so sustainability, circularity, resilience, and also local economic benefits, just the way it happens already in other countries, like France, for instance. And the European Union recent guidance on non-price criteria is for sure a crucial step. If well implemented, it gives the member states the tools to incentivize local content and also to support the development of a truly European supply chain. But at the same time, as also Thor was anticipating before, from a developer perspective, it is very important to make sure that these criteria do not unintentionally aggravate existing supply chain bottlenecks. So ensuring that non-price criteria remain realistic and proportionate will be key to preserving also the bankability and the deployment timelines. And the second point is a fair competition with targeted financial support, because European manufacturers are facing increasing pressure from global competitors. Many are benefiting from strong state support and fewer, let's say, environmental and also social obligations. So to ensure a level playing field, the European Union must actively enforce trade rules, monitor unfair practices, and demand reciprocity in the market access. At the same time, we need also to acknowledge that next generation turbines and floating wind components involve very upfront costs. And these are not just energy projects, they are large-scale industrial ventures, and they come with risks. So that's why targeted public support is essential. Grants, guarantees, and access to low-cost capital through instruments like Innovation Fund or Net Zero Industry Act can help for sure manufacturers to take the leap and unlock private investments. And this is essential because it can ensure that the European Union play a dominant role in strategic parts of the global value chain, including the final the final products. And to make that happen, technology manufacturing projects located in the European Union need shorter and predictable also lead times. So we need to act fast, especially in this kind of emerging technologies like floating offshore wind.
Thank you. I guess that, yeah, Monica, I guess you would like to jump in. Yeah, thanks.
I'd like to just to complete what Filippo said. The floating offshore wind implies specific challenges such as complex permitting, limited port infrastructure, longer development lines, and new grid requirements. So a lot of obstacles during this process. We need regulation that reflects this complexity, not by making things more bureaucratic, but by making them faster, clearer, and more coordinated. Governments should approach offshore wind not only as an energy solution, but as a core pillar of their industrial strategy. That means investing in port, grids, and logistics, accelerating permitting processes. It means aligning industrial, energy, and environmental policy around a shared long-term vision that de-risk investments, scale up deployment, and ensure the energy transition becomes fair. And at the same time, we must invest in innovation to reduce cost, improve the performances, and bring new solutions to make the market faster. In conclusion, in our perspective, Europe has everything it needs to lead in offshore and floating wind. An industrial base and skilled workforce, cutting-edge technology. What we need now is to be aligned between European institutions, national governments, the industry, and the civil society. Floating offshore wind is not just a technological evolution, it's a strategic opportunity to reshape Europe's energy future. Thank you.
Thank you very much. Thank you, Monica. Thank you, Filippo. Thank you, Tor, for having part of this this dialogue with the expert. And now we are approaching the very last part. So we have still 20 minutes, and this last part will be managed by Giulia Butera, which now probably has already some question, probably from the audience, but maybe before that, I just saw a raised hand by Paola Zerilli, and maybe you would like to add something to the previous intervention or to the dialogues we had.
Yes, yeah, thank you. I was just thank you, Riccardo. Thank you, Monica, Filippo, Paolo, and Tor. So I just wanted to connect to what you were talking about. So the relationship between the policy, the regulations, the support from the government, and also how financial markets are going. So, for example, variables such as the interest rates, inflation rate, electricity prices, that all these are very relevant because they are very interconnected. So I wanted to share something about some results that we have from the UK contract for different auctions that, you know, just a second. Sorry, it's not this one. Sorry. I have many things open. Don't know why it's opening this one. Let me share again. Okay. Okay. So as you know, for the contract for different auction, the developers, they get K, that is the strike price, minus the reference price that is connected to the energy prices. So the strike price that they get should be a function of LCOE, so the cost of setting up the technology, so function of CapEx and OpEx. Currently, so this is the last column in this table, CapEx and OpEx, they've been in the recent auctions, they've been set as constant based on the cost of electricity report from 2021, so old report. What we have done is we have done the evaluation of CapEx and OpEx, considering them as function of tax rate, interest rate on debt, inflation rate, and also as supply chain accelerator fund. So in the first column, actually, we just consider the macroeconomic variables, but you see that CapEx and OpEx, they come a lot higher than what they've been fixed, the levels that have been fixed at. When we consider the support from the government, the additional support coming from the adjusted, from the supply chain accelerator, obviously the CapEx and OpEx, they go down. Still, they are higher than the levels they've been set up to. So this is very relevant because means that still what is supposed to be relevant support from the government in order to invest in this type of technologies in offshore floating wind is still not enough, is not taking into account what financial markets are doing. So just to say, in our model, we are projecting the future behavior of interest rate on debt and inflation rate based on our financial models, considering market volatility, for example. And so our point, and what we are also going to put in our LCOE tool, because the LCOE is the main what should be the main reference in order to calculate properly the strike price for the CFD auction. So the point is that CapEx and OpEx and LCOE shouldn't be fixed to some level that doesn't consider what is happening in financial markets, because what is happening to inflation rate, interest rate, and also energy prices is affecting a lot what will be the actual cost for setting up this technology. So that's I just wanted to share with you our observation from UK market, because it will be relevant also for other countries, because I know that in other countries also the contract for different auction is going to be adopted as main financing mechanism.
Thank you. Thanks, Paola. Thanks for adding this. So Giulia, now I leave you the floor for this last 10 minutes of a bit more of questions.
So we have a first question for Ines from Stefano Maram from RSC. So have you considered co-location with photovoltaics? Ines, you already provided a really comprehensive response, but if you would like to add something, just feel free to take the floor.
Yes, we did, and I tried to answer that in the chat as well. We did consider different resources, wave, tidal, and solar, and then we looked at different case studies. So for the Orkney, which is in the north of Scotland, we look at the region where that region didn't actually have high solar resource that will make significant change to the model. However, a lot of the studies, not just this model, but a lot of the study are also looking at floating solar as an option as well as hybrid. So co-location, you have different sites that could potentially work together. By hybrid, you actually use the same platform to put the two. Just to perhaps add to that, we worked with Wave Energy Scotland because they looked at wave energy to co-locate with floating wind, sharing the different infrastructure for the reduction in high cost that all the panelists have actually touched on. Can we still reduce that high cost needed by sharing some of the infrastructures? So yes, we have considered that, but in the case study I presented, that was not included.
Thank you, Ines, for further answering this question. And then we have another question from Valeria Kirilova. So one of considerable benefits of the floating structure is potential smaller environmental impacts on the benthic and underwater communities. How can this argument be more prominent in the industry and or governmental framework? So I don't know if Paolo, since in the MARINEWIND project you have also conducted many work related to and surveys related to the environment and also a work with the local community, if you want to answer this question.
Yeah, absolutely. And it is a very interesting question because if you compare a fixed bottom offshore wind and then you compare it to floating offshore wind, there are big differences. We saw these differences in terms of let's say impact on the seabed, even in the US. In the US, we have a project of 1.5 gigawatt fully consented, where we passed it through all the stakeholder engagement in terms of environmental permit of the foundation on the seabed. And so if we compare that experience to what we are doing here in Europe, so we can see that floating is beneficial for the environment because basically you expose a reduced size of seabed for the mooring lines, because basically offshore wind you have some mooring lines that connects the floater to the seabed. And so basically for sure there is a less environmental impact respect to the fixed bottom installation, and so absolutely is a benefit for the environment, and this is something that is tangible from our experience.
A lot for answering the question. Then we have one question for Thor from Norwegian Offshore Wind. So given the current constraints across the offshore wind supply chain, particularly around installation vessels and fabrication capacity you made, what strategic steps could be governments and industry take today to unlock economies of scale and ensure timely project delivery for the 2030 target as momentum to the 2050 goals? And thanks, Ines, for the question.
Yes, thank you for the question, Ines. It's hard to answer, but I think we are now in an industrial revolution, right? And every revolution or it's more like an evolution because it takes more time, right? But we are kind of in a industrial evolution, and that transition it's going to cost, and it's a risk for company and it's a risk for society, and I mean that is areas where the government should step in and have incentives for covering that transition. I think UK has done a lot on this already. They have set up schemes for the ports. They have what's called green free ports, where if you set up fabrication capabilities, you will get reduced taxes, you will get reduced a lot of the red tape and a lot of the costs. Also in the CFD auction coming now in the UK, you also have a supply chain dimension that is quite interesting for, you know, in a way to establish a supply chain where you have incentives for those type of activities. And I think UK is really a country that we can learn from, because most of the other countries have not the experience and have not had a functional market for a lot of years. So I think it's a lot of learning, kind of the challenges that UK faces now. The same challenges we face. Now I'm talking about Norway. We will face in 4 or 5 years. So I think we have a lot to learn, and I think the government should play a role in making incentives. So this transition from one industry, for example, or if you don't have an industry and into a new industry, is getting as smooth as possible. I don't know if that was an answer on your question.
It is, thank you. And I think we are battling with this challenge because it's still work. Because we have FLOMIS, you talked about the different schemes in place with the CFD, with the clean innovation bonus. Quite interestingly, on the grid side, there's also a lot of work that is being done. But if you look at how we want to scale up, we'll still have that bottleneck of we'll all have purchase orders at the same time for the same timeline. So it's an interesting challenge. I think it's an interesting challenge for all of us, really, because of, and Monica and everybody on the call touched on that coordination. We need to coordinate just not by country, by in Europe and the wider sector, and who does what, really, rather than let's all have all manufacturing capabilities in our countries, which will not really work. So there, you have touched on that. Thank you.
Yeah, just add one more point that I think is not linked mostly to the supply chain, but mostly to the business case. And I think Paola, when she presented the model, the last model she presented, it's kind of it's really interesting, because you have this mismatch between the CFD or the support measures from the government and kind of the market. And the thing we see in the UK, and I believe Ines and Paolo could support me on this, is that the developers is setting up contracts with PPAs, especially towards the AI companies or the data center companies. And this is kind of also a connection. I talked about the industrial evolution here. AI is kind of in the same phase that offshore wind and other sectors, and they are kind of the demand side. And I think it's very interesting to setting up the blended funding of offshore wind project, where you get kind of the industry aspect, where they need the electricity and support measures from the government. Because in the end of the day, and we have experienced this in Norway, is publicly funded CFDs is not very popular by the population. They don't want to spend their money on electricity, sadly. It takes 10 years from now, and the electricity prices will be very high, but then it's too late. So getting blended funding mechanism, for example, PPAs with Google or big AI digital companies, I think is really the way forward.
Thank you to both Tor and Ines for this really interesting discussion, for raising these really valuable and crucial points. And we have 2 more questions for Filippo and Monica from Nadara. So how can an evolved contracts for difference mechanism alongside a coordinated national industrial strategy help the risk investment and support long-term energy security and local economic development. And then we have the one also for Monica. So what do you see as the most pressing gaps in skills, infrastructure, and manufacturing capacity? And how can collaboration between the public and private sectors help bridge them today in the near term?
Okay, thanks for the question, Ines. First, I think a well-designed CFD provides long-term revenue certainty, which is essential to reduce the cost of capital for sure and attract institutional investors. So that's the first point, especially in projects like floating offshore wind, which still face higher upfront costs and perceived risks. And this, if complemented by, let's say, realistic, as we were talking about before, non-price criteria that rewards resilience, innovation, and also and especially local content in a proportionate and predictable way, I think CFDs can also incentivize industrial local development without distorting competition or delaying deployment. And the second point, I think, coupling CFDs with a national long-term industrial strategy allow governments to go beyond project-level support and actively steer value creations. And this includes, for instance, identifying priority ports, which, as you know, is something that has been started in Italy but not yet finished. And supply chain segments, and also align workforce planning and supporting innovation clusters. Because let's not forget that uncertainty brings together risk, and risk is a cost. So we need certainty with a stable and a visible pipeline of properly designed CFD-backed tenders. That's it from my perspective. Thanks, Ines.
Okay, for the question by Ines from me, thanks for question. In my opinion, the collaboration between the public and private side is crucial, is essential. The governments can de-risk the investments through the signal, clear market signal and funding for infrastructure and training, while the industry can commit the proper commitment to concrete project pipelines, coordinate the timelines, and invest in strategic capabilities. So it's important working together, create some partnership. It's crucial. Create coordination and cooperation between the companies and between the public and private side. For the point relating to the skills, in my opinion, we have a lack of workforce, as Tor said also during his intervention, with the right mix to the various capabilities, but we have a mix of capabilities in offshore engineering, digital skill, so we can improve the training programs, reskilling workers from the adjacent sector like oil and gas, the naval, the architectural naval, promoting technical education, and I think it's urgent to create this kind of value and believe in this direction.
Thank you a lot, Monica, for answering the question. I don't know, Ines, if you want to add something to what Monica and Filippo said. Otherwise, we can close the meeting. And I would like really to thank you all, the speakers, for your availability to be here today and for providing really valuable insights during our webinar. And I would like also to thank all the participants who joined us today. And the webinar has been recorded and will be made also available in a 5 different languages, which are the languages of our MARINEWIND labs. And of course, if you want to know more about the project and our ongoing steps, feel free just to reach out to us. So thank you a lot, and have a great day.
Thank you.
Thanks, everybody.
Bye.
Thank you, everyone. Bye.
Thank you.
Thank you.